Well, it's really interesting that we are addressing this question of what has been achieved over the last 10 years with respect to the research portfolio of the Global Water System Project. 1 year ago, virtually to the day, we had a major conference called Water in the Anthropocene. That was a really wonderful opportunity to take stock of where we had been over the last 10 years and really laying the groundwork for where we're going to be going in the next 10 years, in the next phase of the research agenda. What we discovered is that there were some really important strategic issues that were put on the global table that we couldn't have conceived of had we not brought the team together and had people from the physical sciences and the biological sciences and the chemistry of water, and those who were looking at governance issues and economics. And bringing this very diverse team together allowed us to justify the legitimacy of looking at water questions from the fully global scale. Now, we look at things at a variety of scales, right down to the local level, but we recognize that there's a perspective that one gets when you look at the global water system as an integrative system where we can put humans and the natural world together and understand their unique and interacting roles. So I would say that an advancement for the Global Water System Project is first of all, to create a legitimacy for asking and answering questions about how humans and their water environments are interacting at the fully global scale. That was a big game changer if you look at the literature of, let's say, the year 2000. And 15 years later, we can now look back and say that that's been a real development for the project. So the centrality of human beings in the global water cycle was, I think, a step forward in terms of getting the awareness of not only the scientific community, but also the policy community, that it is legitimate to look at these very much broader scales. I think that was, in fact, one of the hallmarks of the effort. One of the other things that we produced along the way was a series of very topical and, as it turns out, very important data sets. And I used in my talk at the conference here this example of the Global Reservoir and Dam Database, which is the state-of-the-art database. It remains so. It was all facilitated by GWSP thinking. We brought together a partnership of workers who began to geographically reference the position and the characteristics of more than 6,000 large reservoir systems across the globe. And we created an analysis indicating yet again that this is one of the major impacts of human beings on the terrestrial water cycle. Now we have a state-of-the-art data set that we can point to, clearly facilitated by the Global Water System Project, and mounted on our Atlas website. So we have a digital atlas water data sets that the GWSP is actually quite well known for. And lots of different people look for water information and come to that digital water atlas that we created. One very interesting visitor to our website was a fellow called Dietrich Beralt, and he is a sedimentologist and engineer who is interested in issues having to do with reservoir sedimentation. And when you begin to look at the aging of reservoirs after they're built over many years, if you're not cognizant of maintaining good land use in the uplands, you find that lots of sediment will roll into these big investments in water infrastructure, and you lose the investment because the water that you were hoping to store turns into sediment that you're storing. So you can no longer irrigate, you can no longer generate as much hydropower. So as he's beginning to develop his business plan, he comes across our website and he looks at one of the data sets that we had worked on, which shows that there's a very, very significant global impact of humans on the sedimentary cycle. And some statistics, or just one statistic I could share with you, is that 30% of the sediment that rolls down rivers that used to find its way to the coastal zone, 30% of that is intercepted by these large reservoirs. So as he's looking at this map, it dawns on him that, well, first of all, it's a global problem. So what he's doing has some substantial significance if he could solve this problem. But he also sees that it's a global market for problem solving. And it dawns on us now after talking to him that this is an ideal opportunity to take the underpinnings of a research-focused project and move that research focus to a solutions orientation. So to take the knowledge that we've generated and not simply generate more and more and more knowledge in a very abstract sense, but in a very specific sense. And so what we'd like to do is we'd like to create an innovation laboratory for creating solutions with stakeholders. And as one example, someone trying to solve the world's reservoir sedimentation issue and problems and challenges, that would be one of the partners. Other partners might be the United Nations and trying to assess how the Sustainable Development Goals might have positive and negative impacts on the environment and positive or negative impacts on human well-being if you don't consider them together, which is fundamentally a nexus question. Well, after 2 days, one can only do so much. But what I've sampled so far in the talks that I've seen is a very interesting early maturity of some of these ideas. So whereas the nexus issue was talked about, let's say 3-4 years ago, in somewhat abstract terms, a lot of diagrams, a lot of text, not too much specificity, and really poking around for the right answers. I now see that replaced with some very, very specific toolkits and data sets and very quantitative analysis to really bring these different issues together. I was honored to have be a facilitator of one of the sessions this afternoon on transboundary nexus issues, and that means international transboundary basin nexus issues. And it was really quite wonderful to see some of the toolkits and data sets that would allow us to ask very specific questions about what is the impact of a water use on the irrigation and agricultural sector, and how does that competition for water potentially impact downstream users of water? How does it impact the legitimate needs of water that nature requires in order to support biodiversity? The downstream users who might wish to have sufficient water to cool power stations. Of course, if you're irrigating agriculture upstream, you're depleting the water, sending it into the atmosphere, and the river is starved for that water, and therefore the downstream users feel that impact. Well, that's a perfect nexus issue that has biophysics involved, it has biodiversity questions, it has human dimension issues, legal consequences, and the specter of international conflict, all bound together by a multi-headed beast of a question. And yet, despite the complexity, I thought that the speakers were able to put some very, very specific pieces of information on the table. And with the appropriate policy dialogue, you could begin to take it from a world of abstraction to a world of specificity and design very specific investment strategies or interventions in really reducing that specter of conflict among different sectors in the economy, conflict among upstream, downstream nations, and conflicts between people and nature. Well, as you might say, it all takes a village. It takes many, many partners to tackle these very, very complicated issues. The issues transcend local scales to regional and ultimately global scales. These are all interconnected. So decision making really reverberates up and down from global to local, local to global. So there are going to be many interested parties around the table. What we're trying to do in the next phase of our water research, really moving it towards a solutions footing, is to be able to take stock of these different perspectives and put them in a common ground, an incubation vessel or experimentation arena, where you could begin to have very productive dialogues between the people who need to solve problems and the people who traditionally are generating knowledge about the system. Because this is such a multidisciplinary and complex suite of problems and challenges, we expect there to be a lot of people around the table. And therefore, we expect there to be a lot of interest to the point where I think we legitimately could consider, as we consider co-design, co-support of the initiative. I should mention we have always been extremely grateful to BMBF for hosting the Global Water System Project for the decade it's been in business here in Bonn. And I think the science that was generated, the integrative research, will stand on its own. I think it has stood the test of time. And it's something I'm very proud of, along with my co-chair, of course, Claudia Paul-Vostel, and the steering committee at large. We're very proud of what we've done. There's more to come, and there's more better things to come because it's going to be solution-oriented. This is going to take, I think, a multilateral partnership of funding. There's, of course, the initial coordination set of activities that the project office here in Bonn has been well known to facilitate and to catalyze, to bring people from around the globe with different perspectives together to solve mutually interesting research questions and now solutions. So there is a decided need for the coordination. But beyond that, we would anticipate that there are lots of new requirements for knowledge, basic research, basic capabilities to assess what a particular policy might do to the Earth system, or whether it really does create mutual human well-being across the economic spectrum, or poor people equally benefiting than rich people in some of these decisions. And so our thought here is that there will be lots of opportunity for assessment, lots of opportunity for basic research, and lots of opportunity to track the progress once policies and good ideas are implemented in the real world. And what we do want to avoid at all costs is not making the sufficient investments in those pillars, the research, the assessment of the Earth system, the innovation process itself, and of course the tracking of the progress. And if you don't have those pieces in place, we're not going to really see if what we've done makes a difference. That's going to require funding, and it's going to require support, and it's probably going to require inputs from the private sector, inputs from the donors, inputs from nation states themselves, who can take different parts of this puzzle and hopefully support this. Yes, our intention is now to bring together the research community, and I will say that the Global Water System Project is well known as a research integrator and synthesizer. So we take existing pieces of knowledge, data sets, toolkits, we assemble them together, and we create synergies that you would not have otherwise realized by working separately. So that's where the value added is in the kinds of research that we've done. In some sense, the first 10 years was more or less a diagnostic process. Where are the problems? Are they truly global in domain? And we shake our heads. Yes, it's quite global in domain. They're also local and regional in domain, of course. So after the lessons of the last 10 years, we understand the absolute need for continued research. So we're going to be looking at a program ultimately that's going to continue to have researchers involved, okay, because there's a real value in that. In addition, we have to bring in people who design solutions. We're going to bring engineers in, hopefully. We're going to bring in NGOs that are very concerned about poverty alleviation. We're going to try to bring in partners who are interested in preserving ecosystem services and biodiversity. They have to be part of this puzzle. We're going to bring the private sector in, hopefully. We'll bring governments in. We'll bring multilateral agencies in. It really is that community of different partners that's going to make this difference here. So what we're trying to do is we're trying to engineer a structure that would allow the infusion of new ideas, the infusion of new challenge areas, new problems that we can jointly solve. I think this is going to be a really, really interesting intellectual exercise. So I'm speaking as an academic right now. And so what it does for me, and hopefully my colleagues, is it really takes this idea that we're doing something for the public good by generating new knowledge. That's a very abstract term. That's very, very abstract. And sometimes when you see someone citing you in the literature or mentioning some work that you've done, you take some great pride in that you've made a little bit of difference. I think this could make a lot of difference, because what we would be doing is we would be optimizing the research, the knowledge generation, co-designing it with the stakeholders themselves. And I can see all sorts of different problems that could be solved. We could solve a series of global scale problems. Like, for example, how do these SDGs play themselves out in terms of the impact on water systems globally and on human well-being? How about carbon mitigation strategies or carbon adaptation? I know that one idea that's been floated, in particular in my part of the world, in the northeastern U.S., is to really manage the forests of that region, and so plant a lot of forests. Well, that's a great idea for carbon management, but forests evaporate lots of water. And so if you're in the business of operating hydro plants, which is in a sense a green technology, you're going to have to be competing against these plantations for carbon management. So it's these nexus issues, traditional nexus issue here, that we really have to begin to create a common kind of fair broker playing field where we could take the science knowledge and begin to look at these trade-offs and look at these unexpected consequences that you might not have considered if you didn't tackle these big challenge issues. So there are global issues like that. What is the impact of world trade policy on water flows? And how about biofuels? At several points in the discussion today, I've heard people talking about how biofuels were not well thought out, the first foray into that, and it really created ultimately panic in the streets, quite literally panic in the streets if you're not careful how you make these decisions. There's certainly regional dimensions of these kinds of questions. How does one manage regional irrigation systems? How does one manage transboundary drainage basins to avoid conflict? How does one transform an energy system that depends on fossil fuel? How do you transform that into one that conveys value to these renewables? All very interesting strategic questions. And we also anticipate that there will be specific problems that come our way. For example, how does one solve the global sedimentation problem, or a sedimentation problem in a particular part of the world where they put in billions of dollars of investment into dams and reservoirs, but the reservoirs are silting up and you're losing the productive capacity. So working with engineers, working with the policymakers, working with scientists, we can hopefully begin to engineer these solutions that are sustainable, that don't negatively impact either human well-being or ecosystem function.
That's a big job ahead.
It is big.
I wish you all the best for that, and I'm curious to follow, and thank you very much for taking the time.
My pleasure, indeed.